So I'm going to talk about the most beautiful code right now, and there are many beautiful code, but it has been said that Quicksort is one of the most beautiful code, and so I'm going to talk about that one right here. And this is not going to be an extensive Quicksort. This is going to be just a simplest Quicksort. Notice that I have a low and high parameters here. I don't see any array and comparison function. Eventually, when you implement this, you will need to have your own comparison function. But I'm just going to talk briefly about the pseudocode here, the idea behind Quicksort. The idea behind Quicksort is basically you want to take some kind of a list, right? You want to have a list over here, and you want to have some kind of a middle value. We call this pivot value, and you want to put everything's lower over here and everything's higher over here. So generally speaking, you want to put a pointer for the pivot and a pointer for the iteration, and as the iteration pointers going that way, the pivot is also going that way, but not at the same speed as the iteration, because what you want is you want to have all the lowers and maybe including the pivot value on the left side, but leave everything the higher on the right side. And it's a recursive, so basically what you want to do, you want to have some kind of a termination condition when you don't recurse anymore. So basically we have a comparison. See, we have if high is less than or equal low, return. It's just to say we're done with the function. We don't do anything. Some people put if high is greater than low and then put a curly bracket here and keep going, and I don't like that because I have to count the curly bracket here, and we'll have to match it somewhere down the line over here. We're done, so we don't have to do anything. We don't have to worry about it. So the next thing we want to do is we want to get the partition going. So we do something like this: for loop partition iteration equal the low value over here, and for so long as the iteration is less than or equal to high, keep moving. And that's basically just a simple way of saying that the iteration is going on all the way to the end over here. Now next we want to compare it with the pivot value. Now the pivot value, you can tell that I'm not doing anything over here. Basically we want to use the contents of the array. Right here, the array number 1 right here, and over here which is the last one, which is high. So that's low and that's high. Now most people would choose the pivot value from the first element, which is the low value. The problem is once you swap it out, it's gone. You cannot keep track of it. So they have a variable called pivot variable. And they set it up to element of array equals to low. But that's not a good idea because that's an extra variable. So you don't want to use this one over here at all. You want to use the pivot value to the last element. Over there. So by the time the comparison gets to the end, you swap it and you're done. You don't have to worry about anything. And that's the problem with most people doing the simplest Quicksort. People doing the simplest Quicksort, they don't consider that they always use the first element. They never use the last element. and that makes it, you know, a little bit extra, and I don't like it. I don't like it at all. So here we use a comparison. If element of array is less than or equal to the element of array of the last one, and that's the pivot value we're using, then we swap the current element with the one with the pivot value, and want to swap it the pivot value and increment the pivot value right there. So right there, increment that. And what happens is you basically gonna put all the lower levels into the pivot value. Next, we do a recursive call, which is basically Quicksort, and low. We're going to do low for here, and high, we're going to change that to the pivot value minus 2, because the minus 1 would be high and would be the pivot value, and we want the one before. We want the one before that, which is the low. And then we do another one over here, Quicksort, and this time we want to use the pivot value and the high, and we're done. So that's basically the most beautiful code right there, and that's what's known as a binary partition. And that's not a good idea, because sometimes the values are basically identical. If you have an arrow with like sorting zeros and 1, as soon as the first partition goes, they all have equal values, so you don't want to do that. You want to do what's known as a ternary partition, 3 ways. So instead of using I less than or equal to high, this would be instead of I less than or equal to high, you want to do it just the equal sign, and because of that, the last one is not going to be the pivot, so we're going to do that into minus 1 over here. And then we do the same thing over here, right here, and we put in the same loops. No, we don't want to set that anymore. We're just going to start with the pivot value. So pivot value, so we're going to start again, but this time from the pivot value, and then we do what's known as the comparing all the values that's identical to the pivot value, and then do the same thing right here, swap A and just put it in that line over there, and you get a ternary partition. So that's the simplest Quicksort. I'll show you the code next time.